converse of some of the postulates and theorems that we had already talked about. Meaning that we were looking at things that we had already talked about, but it was just switching it. So in respect to parallel lines, we were doing it for, in the first sections we talked about, they said that they were parallel lines, and because of the parallel lines and the transversal, then we had all of those vocabulary words. Now we flip-flop it and say, prove that the lines are parallel by showing something is equal. So in the other class, Braden says, all of these exist no matter what, right? So you can still have corresponding, you can still have alternate, interior, exterior, and so on and so forth, even if the lines aren't parallel. Right? So they will always be there, they're only equal, and if you can prove they're equal, then the lines are parallel. Or in case of consecutive interior, then they're equal to 180. So in this case right here, it says find the measure of angle ZYN so that PQ is parallel to MN. So they're basically saying prove that those two quantities are equal to each other, and if they are, then your lines are parallel. So what relationship does this quantity have with this quantity? Alternate exterior, right? So when if they ask you to, or a y, then that would be your y, but you should really say the converse of alternate exterior, because we're going backwards of it. Okay, so what does it mean for alternate exterior angles? What are those two quantities to each other? They're congruent, so I'd set them equal to each other, right? You need to see the math. Anybody? Okay, so and then make sure, once again, that you answer the question. So here's my next one. It says find x so that GH is parallel to RS. So the biggest thing is in some of these is that you make sure that you understand where that quantity is compared to this quantity right here. And you really have to pay attention to the little arrows and everything. So again, this isn't necessarily how we usually write our parallel lines. So in the book, you might have to rotate the book. So if this bothers you in this kind of how it's looking, you're going to flip your book and look at it like we would normally do. But in either case, these two quantities would be considered what? Alternate interior this time. And again, then we would just set them equal to each other and solve. Right here it said solve for x. In the last one it said find a specific angle. Now in these cases right here, if it's alternate interior, alternate exterior, or corresponding, it doesn't matter what quantity I use, right? Because they're equal to each other. If it's consecutive interior, I can't just stick it into one or the other and that both of my answers. Unless they would be 90-degree angles. But that's probably not going to happen a whole lot. So consecutive interior, you're just going to have to actually do some math to it to figure it out. Oh, sorry. Do you want to see the math on that one? It's basically just setting those equal to each other, right? And this one right here, this is more of kind of a thinker. In the game tic-tac-toe, 4 lines intersect to form a square with 4 right angles in the middle of the grid. So even though that they don't show that to you, they say it, so you have to basically believe that that's true. It would have been a little nicer if they would have shown the right angles by putting the boxes in there, but they don't. So is it possible to prove that any of the lines are parallel or perpendicular? If I know that this is a 90-degree angle and this is a 90-degree angle right here, can I prove that anything's parallel or perpendicular in that case? Yeah, that would have been that last theorem that we wrote up there yesterday. If it is perpendicular to one line, then it has to be perpendicular to the other line that it is parallel to. Okay? And so this is just showing you that you could actually use that theorem in that case. Any questions? So The rest of the time is yours to work on that, right there.